Let's take a look at what checkpoints can do for building some recoverability into our SSIS packages. What checkpoints do is they allow us to designate restart points inside our packages at the control flow level. When we configure a package to use checkpoints, SSIS will write out package execution data to a text file, and we'll be looking at the format of that in just a moment. If a package fails and we start it up again, SSIS can use the information in that checkpoint file to enable restart from the point of failure under certain conditions, and that's what we need to sort of explore here. Now, if the package successfully completes that next time, that checkpoint file is deleted, which is to say, then the next time that you start the package, it starts from a blank slate. The good news is that implementing checkpoints doesn't really take much work. However, it's the planning for and designing a package to take fullest advantage of them that's going to take a little bit of work. So to implement them directly, at the package level, you'll enable checkpoint file usage, and you'll enable the checkpoint process through three properties. Checkpoint file name, which, like it sounds, will allow us to set a path and file name to where the checkpoint file is written. And this would be a great use of configuration properties. Checkpoint file usage, which tells SSIS what to do when a package starts. Do we start if a checkpoint file is found? Do we always start? Do we never start? And then, do we save checkpoints into the checkpoint file at all? And a combination of those three settings must be set up for this to work. Now, the actual determination as to how a checkpoint will restart is set at the task host level, which is to say the lowest level of a control flow task. An individual task dropped right onto the designer can be set to cause checkpointing. A sequence, a loop container, any of these can also be set to cause checkpoints to be written and for restart to happen. The way you'll do that is you'll set up the fail package on error property. That tells the package if this particular task fails, the whole package should fail. So we would ignore, for example, precedence constraints. Well, if we fail at that point, that's when the checkpoint file will get written to, and information will be stored in it that tells us what happened and what was going on at the point of failure. So the next time the package starts up, SSIS checks for the existence of the file and compares it to the properties that are set for the package. And if that file exists, it'll use the contents to determine the start point. So it'll know at that point which task should need to restart. So some considerations, and then we'll take a look at this in bids. First off, what's in this checkpoint file? Well, a couple of key values are written. The package ID itself, the execution results, what failed, for example, any variable values, because we may need to bring those back in to be able to resume. Now, all of this is written in a flat file format, and we don't have any control over that. As it turns out, if you look inside the file, it's XML, and this probably shouldn't surprise you at this point in Microsoft's evolution. The biggest consideration, and for some people it really takes careful design to work around this, is that since checkpointing happens at the task host container level, a single control flow task can be checkpointed, and a data flow task is a single control flow task. However, as we know, it's a very special kind of control flow task, which in turn can host sources and destinations and transformation components and so forth. But we are not able to checkpoint the partial completion of a data flow. The data flow either fails and we start again at the beginning of the data flow, or it succeeds and we proceed with the next piece. But we can't say if part of the load succeeds and then it dies, pick up where we left off. So again, you're going to need some careful design to make this work. Well, let's go take a look at an example of this in play. In this demonstration, I've contrived a package that will illustrate the best features of checkpoints. Let's review what I've got here. In the control flow of this package, I have a data flow task with a precedence constraint on success to a file system task called delete archive file. And if we go into the properties of the delete archive file, we'll see that I am using a file system task to delete a file called archive.txt. And if we drill down into the source connection, that archive.txt file is sitting out here in the file system. Now, the fact that it's empty doesn't really matter for our purposes, but if you look over into the attributes column, this is what's going to trigger the checkpointing behavior. I've marked this file with the read attribute. If I look at the properties, it's set to read only, which means that this hapless delete archive file task will fail. Now here's the scenario. This data flow task, which is going to be pulling information from some database into some destination, in this case I'm just using a data reader, this is going to take a while to run. And I want to set this up so that if something goes wrong with this delete archive file, I don't have to start that whole data extract again. And this is where checkpoints really shine. So here's how I've set this up. At the package level, I have set several key properties to make checkpointing work. I have specified a checkpoint file name, so I'm pointing to a file called checkpoint.txt that will live in my project directory. And there's an empty file called checkpoint right now. I've specified that the checkpoint usage is if exists. So the checkpoint will be used if that file exists. So in other words, if that file exists, that means the previous run must have failed, in which case I'm telling it to start up from that point. And then finally, I'm saying to actually go ahead and save checkpoints, take advantage of this capability. Now, what I've done to make this finish out is I've also marked a property of the delete archive file. The property in particular here is this one, fail package on failure. So when this task dies, mark the whole package as having died so the checkpointing knows where things happened and allows me to restart from that point next time. So what I'm going to do is I'm going to go in and first remove that checkpoint file that's already there. So we're effectively starting clean. Let's go back to bids. And I will run my package. So we'll pull some rows out of the data flow. And when that succeeds, because of the precedence constraint, we should move on to the delete archive file. Okay, well, we see the data flow task successfully completed and then moved on in the control flow to delete that archive file, which we know can't happen, so we expect it to fail there. Well, I'll stop the package and I'll go out to my file system, and sure enough, there is checkpoint.txt, and let's peek inside. We see in XML format some checkpoint information, which is storing the package ID, any variables that were set, and then information about the container, information about the contents of the package, any results, any precedents. And in this case, it's fairly lightweight because, as we see, there was just the one data flow task, so we've got a pointer to the data flow that succeeded. Well, all right, well, let's see if this all works as designed. Back to bids, with the checkpoint file in place, and with the package set to use that checkpoint file if it exists, what I expect to have happen when I execute the package is that the data flow task will not execute again, and the delete archive file will attempt to run. And to set that up for success instead of failure, I'm going to turn off the read-only flag. All right, here goes. Let's see if the package picks up on the proper task. And it's completed. Note that the data flow task didn't go yellow, didn't go green, certainly didn't go red. The data flow task never ran. We picked up right from that second task, and we successfully completed. To close that loop, I'm going to go out to the file system, and I'll notice that that checkpoint.txt file is no longer there. When the package completed successfully, it deleted that checkpoint file. And just to show that that file task succeeded, you'll note that archive.txt is no longer there either. So I hope you see how we can identify a package and its components to be able to use checkpoints, to be able to save time when things go wrong. But bear in mind, if I had wanted to have the data flow task resume on failure, the whole data flow task would have to resume. I can't go into the components on the data flow and say, pick up from this particular transformation or pick up from that. It's the whole data flow or nothing. And in this case, the data flow succeeded, so I only needed to worry about the file system task.